Hello and welcome to another episode of GSC at Home's Powering the Future Week. Today we're going to be learning about this, popcorn. You might have eaten it at the cinema or as a quick snack. In the UK we eat about 15,000 metric tons of this stuff a year, which is quite surprising because of how light it is. Before popcorn is the soft white food that we eat, it starts off as a popcorn kernel. Now, the popcorn kernel is the perfect design to show us that everything in this world has energy. Popcorn kernels are the seeds of the corn plant that it's grown on. It looks a lot like corn on the cob when it's growing, but it's much harder. It needs to be popped to be eaten. It takes about a jar this size of popcorn kernels to make a bowl of popcorn about this size. Did you know that energy can't be created or destroyed? This means that if we do nothing to the kernels in front of me, and they only have the energy they started with, they are going to stay exactly as they are for a very long time. So let's try that. Okay, so I'm right, the kernels don't have enough energy to pop on their own. So let's try something else. So energy can't be created or destroyed, that's a scientific fact. And because the popcorn doesn't pop on its own, we know that there's not enough energy inside there for the popcorn to pop. So we need to add some energy. Traditionally, popcorn is baked in a pan. It's heated up until it pops. In that reaction, the energy in the form of heat is being added to the corn. By adding heat or thermal energy to the kernel, we are increasing the energy in the water of the kernel, the kinetic energy. Kinetic energy is the energy of movement. When you push the pedal on your bike and it moves forward, that is kinetic energy. Well, by heating up the water in the kernel, it makes the bits that make up the water move about really quickly. To understand that movement, you should know that water is made up of tiny parts called molecules, and that these molecules can take three forms: solid in the form of ice, liquid in the form of water, and gas in the form of steam. When the molecules are in ice, they're moving around incredibly slowly and are packed together. When they're in liquid, they're moving about a bit more, not very quickly, and are quite close together. But when they're heated up, these molecules start moving around really quickly and need space to move around, creating steam. So when we add heat to the popcorn kernel, we're making the molecules move around really quickly by increasing their kinetic energy. Water turning to steam inside the kernel builds up pressure, and the water molecules are just so desperate to get away from each other. But this isn't made of water. There's something else inside our popcorn kernel: starches. Starches are complicated parts, similar to sugar, that a plant seed would use to grow into a plant. When the water molecules are moving around and heating up, the molecules that make up the starches are heating up in a similar way, but they don't turn into steam. They make a jelly-like substance. Everything inside is moving about more and needs way more room. The movement builds up pressure until it pops, starting with a small tear that everything pushes out of at once, splitting the hard shell and letting the steam and jelly out. The steam evaporates into the atmosphere and the jelly cools, slowing down the movement of the molecules and forming the soft, white popcorn. The hard shell doesn't go anywhere, it stays attached. In fact, you've probably had some of that stuck in your teeth before. Some of the energy is transformed into sound, giving us that little pop to let us know that it's ready, and the rest of the kinetic energy is given off to the atmosphere as heat. Another way to cook popcorn is similar, by placing it in the microwave. I have a bag of microwave popcorn here. When you put it into the microwave, the radiation, also called microwaves, bounce around the box and hit the kernels. When they hit, they speed up the water molecules, much like the pan does. This allows us to make popcorn really quickly and in a much safer way than using the pan. If this video has inspired you to make popcorn at home, make sure to be safe. It can be really hot when it comes out of the microwave, so make sure you have an adult on hand to do all of the cooking for you. Before I go, can you think of any other foods that move as they cook? Or can you think of any ways that you use kinetic energy to get around? Let us know if you work out how you use kinetic energy and if we've inspired you to make popcorn of your own. Thank you for joining me, and join us again tomorrow at 10 AM for more GSC at Home.